Hello, hello. Welcome to the stream. Haven't streamed in a long time, about 2 weeks. Uh, and yeah, well, in the meantime, what I've been doing is I've been setting up the Steam page for Shakedown Rally and working on the trailer and stuff. But yeah, that is why I'm not streaming recently. Just so you know, yeah, this I just wanted to do a little stream of Zig because on Sunday I was part of a game jam. And well, I was working alone and I wanted to do something. So I was like, okay, let's try something completely new. And then I wanted to try Sokol for a long time. Well, I will show you what it is in a moment. But yeah, basically I just started from scratch. But yeah, let me get ready and I will begin and talk about the whole thing. Okay, let me see. What do I need to do? Sokol. Hello, hello, Coopert 1 and 0. Nice to see you. You say Sokol is cool. Have you used it before? Yeah, this is the first time I heard all the best about it, but this is the first time that I actually tried it. So I've never even used the C version. I just straight went into the Zig version, but of course it's very similar. It's just different bindings. The weird thing is though that I need to look at C samples because not all examples have been rewritten. Okay, yeah, okay, this is the beginning. Sokol Zig. Let's see what do I need? I tried it recently, says Cooper 1 and 0. So what do you think about it? Let's Cooper 1 and 0 says very easy to learn and set up, but I think it's almost too minimalistic. Oh, you think so? But it can do a lot of things. Like I'm actually impressed by the uh, um, by the examples. And the thing is that you say too minimalistic, but then what is? Oh, I'm sorry. Did I actually adjust? Oh no, I was probably too quiet. Okay, now it's better. I forgot to. I was using the my Zoom H5 here for because I use it for recording sounds and for this for streams. So I was recording some sounds outside. Completely forgot to readjust it. Okay, to the streaming volume. Okay, so yes, if you think that Sokol is minimalistic, what is Raylib then? Like Raylib is way more simplistic. Like that is what I would say. But yeah, what is cool about Sokol is that it is cross-platform, right? And Yeah. Okay. So let me slowly begin, since people are coming. Uh, let's see. Raylib is not a graphics API, it's almost an engine. Yeah, that's true. That's true. Yeah, Raylib is like it has a lot of optimizations under the hood, I think. Um, but yeah. And of course it has so many other things in it. But Sokol has a lot of things as well, like audio and input, and so it almost feels like an engine as well. Uh, Although, of course, it's much more of you have to write your shaders. Anyway, yeah, let me begin. Oh, I didn't. Wait just a moment. Color red. Mm. Okay, I think I have everything set up. Okay, so let's begin. Welcome everybody to the stream. Welcome to some Zig again. And we are back well, we're not back. This is a completely new project. This is how much I have written so far. So what is this about? I don't have, since this is the first stream, I don't have even any to do. So let's do a to do. Well, this is probably going to be a one-off stream, but let's do it nevertheless. Okay, so what is this? Well, our main goal today is to draw a circle. Okay, draw a circle. But what am I doing? I am using Sokol in Zig. And well, this was part of a. What are we doing here? Yeah, well, if I put, yes, good. I have Sokol and Zig. And today, we're going to draw a circle. So yes, using Sokol and Zig. It was part of a game jam that I was on Sunday. And I actually, well, I was working alone and I wanted to try something new. And for a long time, I've heard good things about Sokol. So, what is Sokol? Well, Sokol is this. It is a minimalistic cross-platform standalone C headers for, well, it doesn't really explain what it is, which is weird. Minimal cross-platform standalone C headers, but it doesn't say what it does. It's a renderer. It's basically a renderer. And the cool thing is that it is very easy to include into your projects because it's just header only, STB style. And of course, it is STB is famous for STB image, the image loader that almost every game engine uses, I think, today. Made by Nothings. I forgot his name. Sean Barrett. That's his name. Yeah, who was one of the original renderer programmers on Thief games back in the day. Anyway, but yeah, it's kind of like he sort of inspired a lot of other people to do STB style single header libraries. So what does Sokol do? Well, it's basically a rendering engine, and you have a lot of live samples here. One of the coolest thing is that it's cross-platform, and it can compile to any backend. So whether it's OpenGL, DirectX, Vulkan, or even WebGL. So here are the WebGL examples that you can find. And by the way, GitHub is Fluch Sokol. But just Google Sokol and you'll find it. Um, and yeah, so basically it goes from, there's many examples from the simplest to, of course, there's triangles to even something way more complicated, like, what is this? Transforming shapes. Look at that. Beautiful. I hope that everything is working, by the way. Yeah, looks like it. Yeah, UV wrapping. But this was actually the most impressive one. It's like a storage buffer. Oh, storage buffers not supported. Wait, which one was it then? It was not about storage buffers. It's about instancing animations. Oh, it is this one. Yeah. So storage buffers not supported. I think maybe it's because it's Firefox. And maybe they're implemented in Chrome. Who knows? But anyway, this was one of the most impressive things. Oh, GitHub IO has control of your pointer. It's kind of weird. So this one is running at like 60 frames per second. Maybe not on stream, but normally it does. And you can just increase the number of instances to like 500, and there's absolutely no frame drops, which is pretty amazing. And this is just WASM, WebAssembly. And it uses ImGUI, of course. You can even draw it, and it's running in the browser. It's incredibly impressive, and you can I even tried it on the phone, so you can really, yeah, it's just a pretty impressive and fast, and yeah, I am thinking about using it. So yeah, the reason why I actually wanted to try Sokol is that I'm trying to perhaps use that for my future engine. So when I'm gonna like do the next iteration of my engine, well, oh yeah, by the way, very important news. I got a name for my C++ engine. So the C++ engine which runs Shakedown, in case you are wondering what it is. Wait, let me actually shut this down so it doesn't use all the open. Yeah, this is Shakedown, my game that uses OpenGL and C++, and I decided to call the engine running this. Let me not have so much audio. Well, actually, this map is not that impressive. Let's go to, oh, well, yeah, let's do Finland. I do have to switch between tracks outside of the game right now. That's a known issue, of course. But yeah, so the name of the engine is going to be Recce, and that is written R-E-C-C-E. Why? Because in rallying, Recce is reconnaissance. That is when cars drive around and they write down pace notes for like when is something coming up, what kind of corner is coming up. And since Recce's always come before Shakedown, that is why I decided to call the engine Recce. But yeah, I don't know if I'm ever going to use the Recce engine for anything else than Shakedown, because I kind of want to proceed on making a better engine, and I want to move to Zig from C++. So that is why I was thinking about, since Shakedown engine, well, the Recce engine is written in just in OpenGL and doesn't use anything else. I was thinking about this time using a different, like a rendering engine, instead of writing everything from scratch in like OpenGL. So yeah. Anyway, I am driving slowly to because I'm also talking and thinking about it. But yeah. Anyway, so yes. There you go, Recce engine. This is the Recce engine now, not called the Shakedown engine anymore. and probably gonna be just used for this game. Although I do have another game from back in the day, but that was like 2 weeks in the engine that I published a long time ago. But yeah, anyway, yeah, let's go back to Sokol because this is not about. But yeah, in the future, hopefully, I want to use Sokol for a future engine. Okay, so Cooper 1 in 0 says Raylib is not a graphics API. Yes, I read that. I think Sokol has helper functions for drawing 2D primitives like circle and stuff. Oh! No, let's not go the easy way. Let's do it more complicated, because why not? Let's draw the circles ourselves. But it's actually not the issue. Like drawing the circle itself is not so. It's not so complicated, right? To create a circle. The more complicated thing is to issue draw calls and everything. Because, so what is the problem? So today I want to draw a circle, but let's do it like this. And to draw a circle, we need to do a few things. And first, I need to figure out okay, well, I do want to guide through the code first. But to draw a circle, we are going to need to figure out how to draw, draw indices instead of vertices, instead of like triangle elements, because right now this is how I'm drawing the triangles. And then after that, I'm going to need to create a circle mesh, so to speak, right? The vertices. And finally, we'll be able to draw the circle. Let's make the circle also move as well, because I think I might do this quickly. So make the circle move with some uniforms. So okay, let me show you what I have so far. So today I started by, well, this is what I managed to do on the initial, window, flashy green, triangle. Yeah, let me actually guide you through. Okay, I don't have this saved, right? Okay, let me guide you through cleanup, triangle shader, and pipeline. I think this is checkout commit. Yes. Let me show you. This is the old one where I only managed to create a screen. So this is basically what I managed to do during the game jam, which was, just maybe an hour of work because I was just hanging out and fooling around. I'm actually surprised it's taking so long. Maybe it's because of this. Maybe it's because of the stream. Or maybe I didn't. Oh, by the way, one more thing that Zig is going to get in the next update. They are working, actually right now, it's even available, is the new compiler, which is not LLVM, and it doesn't use the classic linker, but it's using their own linker and compiler, which is going to make Zig incredibly fast to compile, which I'm looking forward to. But the problem is that this doesn't work yet on Windows, so that is why I'm using the old compiler, which is slow. Well, not slow, but comparatively slow. So yeah, this is what I got on the jam. It's just a background that changes. It's just the screen color, right? I'm changing the green and the red and animating a bit. And what I noticed immediately out of the box is that Sokol actually works, the graphics are actually in a separate thread, which is super nice. So moving the window doesn't block the game. This is a problem that I actually have in Shakedown. So they have solved this out of the box, which is pretty cool. One thing is like if you're resizing, there's no like black squares around, and because right now in Shakedown I have a super complicated process. They have actually solved this in Sokol much more smoothly. I noticed that when you resize the window as well, the minimize button goes over. This is probably a Windows problem, but it's funny. The minimize button leaks over across the window on the behind. So, and you can also completely collapse it down. I don't know. I don't know if this is meant to be or not. I guess you can set your minimum and maximum ranges for for moving the window. But yeah, anyway, that's completely that's completely irrelevant. The cool thing is, you know, that works. Okay, and then after doing this, today I wanted to make a triangle. And so the difference between this and the triangle is that I've added, of course, the vertices, attributes, and of course, yes, in this case, when you want to draw something, of course, you need a shader. And so I want to take a minute to talk about how shaders work in Sokol, which is kind of interesting. So let me see if this actually works. No, I think it's the triangle that is the actual one. Let's see. The thing is, yeah, there it is. This is the triangle. Thing is that since Sokol needs to provide shaders that work across different backends, meaning it needs to work in OpenGL, it needs to work in Vulkan, it needs to work with WebGPU. It needs to compile shaders differently for every different backend. And the way that it solves this problem is that it has this kind of a triangle, well, not triangle, but like a shader glsl.zig. And when I saw this in this file inside the examples, I was so confused. I was like, what the hell is going on here? What are these bytes over here? What do I do? Oh, this is nice. Nice overview of what the bytes are. And I was like, what the hell is this? Do I have to write this myself? But of course, no, you're not supposed to write it yourself. If you go to the top of the file, it says machine generated, don't edit, which makes sense. And I was like, okay, so how do you generate it? Well, it's generated by Sokol, SHDC, shader compiler. That's what it means. Should see, like the shader compiler. And that one you can find in a different repository, which is basically, where is it? Where is the, well, maybe I need to SHDC, no. Okay, it is somewhere in the tools. Let me do Sokol HDC, okay, there it is. So yes, basically you come to the Sokol tools GitHub, and then you need to download, well, there are actually binaries that you can download, and that's actually here, precompiled binaries. So what this is that it is a compiler that will convert your shader, which is written here, right? This is the shader, super simple, and it will convert it into this zig file. Which is machine generated. So what it does is that it compiles for everything that you need. And what I need is actually in a bat file, which is not in this commit, but it's a bit later. Okay, let's go back to the two triangles. Okay, there it is. So this is my bat file. Basically, what I do is the input file, the output file, The input is the GLSL, the output is the Zig, and in this case, I'm outputting into a second one, into triangle 2, because I didn't want to mix it with the original triangle. And then you have to define which languages do you want it to compile, and you separate them with the colon, I guess. So GLSL for 10 metal, HLSL, you know, everything, and WGPU, and I have to specify that this is a Zig. So this needs to be formatted as a Zig file, because by default it will give you a C file. And then what you do is inside your main, inside your game, you're basically just importing this shader. And then this is kind of a cool bit of this shader compiler, because what it does is that it takes all the uniforms, it takes all the attributes as well, and it turns them into code, so you can actually fetch them and have static, static asserts and everything. You know, make sure that it works at compile time, which is pretty cool. For example, I've added into the triangle fragment shader, I've added the here is my uniforms. And by the way, I started by doing this. I started by using just a uniform offset like this, but look what happens. If I try to compile, this is interesting. So basically what this is it's a uniform. Oh, it needs to have a of course format as well. This is a uniform that I set in the fragment shader so that I can pass it into something else. In this case, I'm just multiplying the color so that I can assign this offset at runtime and change the color of the triangle. Yeah, but basically what I do in Shakedown is this is how I define my uniforms, right? But then I try to compile. Let's run this bat file, and it says what is not recognized and is in it, what? So-called Zig is not recognized as a what? External oh, because I selected. I guess because I accidentally selected. No, this is what it is. Okay. And look at that. It says error. Non-opaque uniforms outside a block. Not allowed using GLSL for Vulkan. Interestingly, Vulkan, I guess, doesn't support uniforms that are not in a block. And so that is why, which of course I'm not using Vulkan in Shakedown, so I didn't need this. But yeah, you actually need to put them in a block, right, like here, and then it will actually compile. So if I run this again, it says nothing, which means that it's done. This was also confusing because it just shows you the command, but then it does nothing. Okay, so yeah, this actually compiled into the triangle too, which is cool. Okay, so right now I have to do this manually every time I change the shader, but it's okay. I will try to add it into the build system at some point. I guess, I don't know if in Zig you can, if I can somehow go like, yeah, I probably can, yeah. But I mean, just like, oh, do something before running the exe. Maybe I should do it here, like run compile shaders bat file. Yeah, it's probably like a sub process. Maybe there is the std os or something like that. Os run, no, process, no. There must be something, right? No, this is Windows. So maybe that's not the right. Okay. Let's actually try to do this. Okay, right now. Even if I didn't try to do it. Okay. Zig run sub process. How do I do that? Is it possible to execute a shell command from Zig? It must be possible. I mean, that's one of the most... Something like Fortran's execute command line. Oh my god. Yeah, good, good example. You can see who this is coming from. This question. Yeah, it is OS actually. OS. Oh, get. Okay. Wait a minute. I just found in standard library that I was looking for. For example, here's one thing. Okay, you get a directory. That doesn't answer the question. Yeah, it doesn't. How can I execute a shell command? I think you may want to look at execv. Okay. Oh my god. This function must allocate memory. Oh no, it takes an allocator. To add a null terminating bytes on path in each argument. Here's my cross-platform API. Here's the cross-platform API to do it. Oh no. Yeah, wait. This is just getting the... So what was it again? execv. Isn't it in the OS? It is in the OS. So maybe it doesn't exist anymore. Access, it doesn't have anything interesting populated by startup code. What is access? Call from... Yeah, I'm already stumbling upon. So let's not do that. Let's just go draw in a circle. Okay, I will figure this out some other time. Unless somebody knows from chat how to do it. Okay, so yeah. So what am I doing here in this one? Well, this one actually draws... yeah, I do actually want to run this like this. And what I do here is I draw two triangles which are changing the colors. And you can see this, the triangle is becoming black after a while. And the reason why it's becoming black is because the color is being multiplied by this offset.r. And in my case, that is happening in, where is it? Apply uniforms. Yeah, basically what I was trying to do here, I was trying to figure out how does applying uniforms work? And does it work with, yeah, can you actually apply different uniforms at different times, right? To a different, yeah. And the thing is that you basically say apply bindings and you bind these bindings. The funny thing is that, yeah, in this case, I'm rendering two triangles with a vertex offset. So these are like two completely different buffers of triangles. It's not one triangle that is drawn with an offset, which is definitely not how you should draw triangles if you have exactly the same ones. But I just wanted to try how to draw two things at the same time. But I definitely don't need that. I should probably remove the bind. Yeah, I am a bit confused about the bindings thing, because it basically has a vertex shader, a fragment shader, and vertex buffers and index buffers. So it doesn't support anything else, I guess. Or maybe there are different bindings for different things. I am not quite sure about that. And the interesting thing is that the vertex buffers they have 8, the size of it is 8, which I don't know if this is a some kind of, yeah, it's strangely hard-coded to 8. I'm not exactly sure why. If this is some kind of a hardware limitation, but I doubt. I think this is just Sokol decided to do it with 8 bindings. Okay, Yeah, so for the beginning, before we start drawing the circle, let me actually remove this other triangle because I don't wanna draw anything. So yeah, I'm gonna need to remove this binding. And where else am I had this bind to. Okay, yes, apply bindings, apply uniforms. I don't need to do it twice, and I don't need to draw. Okay, there it is. So we have just ending the pass, drawing, and that is it. And commit. Let's put a commit as a separate thing. Okay, let's try. There it is. Okay, there's only one triangle. That's pretty cool. Okay, so let's turn the triangle into a circle. But first, I have to figure out how to draw with indices, because for a circle, I'm going to need indices. King Sam J says it's the stage bindings, right? And I don't know what does that even mean. So here's the thing. I've only programmed graphics in OpenGL, and in OpenGL, you know, it's just a state machine. So you're like going through and you're binding individual buffers. But when it comes to like stage bindings, lol, it sounded like you were wondering about how to bind stuff that wasn't vertex index buffers. Textures in Vulkan are done per stage. Textures. Yeah, I'm wondering about textures. Are textures just buffers in Sokol as well? I'm not sure. I guess I didn't yet get to the textures. They're images in Sokol. Okay. Textures in Vulkan are done per stage. Yeah, I mean, okay, that does make sense, right? The vertex fragment stages. But no, what I was actually wondering is, why is there up to 8 of them, right? That is because that seems to be hard-coded by Sokol. There it is. You can have up to, yeah, well, here are the images. You were talking about images. Yeah, in each of the stage bindings, you can have up to 12 images, 8 samplers, and yeah, 8 storage buffers. What is the difference between samplers and images, though? That is a bit confusing. If I use sampler 2D, right? Because that's how you do it when you're passing in a uniform, right? You do a sampler 2D, and then you have your texture. Is this an image or is this a sampler? You know, yeah, exactly. And the hard-coded limit is probably just a Sokol-defined arbitrary limit. It might map to hardware limits. Yeah, but yeah, I don't think I've ever even needed more than that, more than 12 images in a shader. So anyway, yeah, completely unrelated, but still interesting to ask about. The sampler 2D in the shader is a combination of an image and a sampler binding. It's kind of confusing. Okay, so if this is a combination, so okay, here's another question, philosophical question. If you have sampler 2D, texture 1, and you have texture 2, and you have texture 3. Is this one sampler with 3 textures, or is this 3 samplers and 3 textures? And if it is 3 samplers and 3 textures, then why does Sokol have, where was that? Why does then Sokol have 8 samplers and 12 images? It's 3 textures and 3. But why would there be more images than samplers? That's my question. Then, why is it not like 12, 12 or 8, 8? If that is what you're basically going to use it for, right? I don't know. Maybe there's a cube map or something which does not need to be sampled twice. No, but that's, even that is a, yeah, I don't know. Yeah, I can't answer that for Sokol, but you can technically bind images and samplers separately in the modern graphics API. Yeah. So yeah, maybe if you're using like Vulkan backend specifically or something like that, maybe you can do that. But yeah, since this is basically OpenGL code, then yeah. Anyway, let's go on to try to draw indices. So right now what I'm doing is I have these triangle vertices, right? And I bind these, I put them into a buffer, right? And I say make buffer. Yes, so this thing creates a buffer, which is nice, much cleaner than in OpenGL, which I use for shakedown. There's just the one there's just the one function, and it's like data. And what are the other things? Label, MTL buffers, type, usage, buffer type. There's also some types. Index buffer. Oh, here we go. Index buffer. So maybe I am supposed to do it with an index buffer as well, right? But so what does default even mean? Does that mean vertex buffer, since we're using it as a vertex buffer and I didn't specify? I guess. What if I put in a vertex buffer? No, what dot vertex buffer. And I forgot to put a comma, right? Is that still going to work? Yeah, okay, so it doesn't really matter if you put a vertex buffer or not. Okay, so what I do is I create a buffer with triangle vertices, and this as range basically converts into the Sokol. When I say Sokol, it sounds like I'm saying so cold. It's so cold as range. No, I mean Sokol, right? It uses it's basically its own kind of a span thing, right? It says here, helper function to convert anything to a range struct. So a range is basically just a span. It has a pointer and it has a size. Look how simple to read this code is, like in Zig, right? If this was written in C++, it would be like, it would be a mess. I'm pretty sure. Okay, anyway. Yeah, so when it comes to, yeah, basically this converts to the Sokol representation of the ranges, and yeah, you can put any data into it and make a buffer out of it. Pass it as the data. So this doesn't make a copy. This just creates a span, which is a view into these vertices, and it totally knows about the size and everything, which is very nice. Okay, so yeah, I had his vertex buffers, and then, well, I actually moved them here, but I don't need to move the vertex buffers because because I have only one triangle right now. And then what I do here is I create a shader. Okay, I assigned formats for the attributes, sorry, create a pipeline, and then Oh yeah, okay, this is for the colors. And when I render the frame, I begin the pass, assign the swap chain, apply the pipeline, and then I say draw. And what does exactly draw mean? What does draw exactly mean? As you draw base element, why is there a double? I guess. But how do you actually draw with triangles, with indices, and not with, okay. So yeah, this is where I need to look into the examples. So I'm going to launch another Visual Studio Code, VS Code, and I'm going to open the folder that I already did recently, which was, where was it's this one, because this is where the examples are. Yeah, basically there's this quad example, and in this quad example you are actually reusing the vertices. So the quad has 4 vertices and it has an index buffer, and there it is. Okay, so yes, there it is. It creates a buffer and it assigns the type of to be index buffer. And then how does it draw it actually? Okay, it still draws with 0, 6. Okay, 6 meaning triangles. Interesting. Okay, so it's still, it doesn't say, it's not like in OpenGL where you say like draw with elements and draw with triangles. It's like 2 completely different things. I don't know where I'm actually defining this. Am I defining a triangles somewhere? It's applying uniforms. Interesting. Okay. I guess not. Or is that part of a pipeline? Okay, let's see. Where am I initializing my pipeline? Okay, there it is. Index type. So yes, I do have to define an index type. I wonder what it is by default. The index type is, well, it says .default. But what is the default? I have no idea what the default is. Interesting. But where do I ever actually define whether to draw with elements or with triangles or not? Or if you just don't have an index buffer, it will automatically draw. This is interesting. Okay. Well, let's try to do that. So let me create, for this one, let's create a new buffer. And I'm gonna have to make the, do I have to turn, no, I actually have just the index buffer, right? Index buffer, and I'm gonna make a buffer. And that is going to be, type, of course, as we said, it's going to be the index buffer. And the data is going to be as a range. And we're going to create a new U16. Let's go with U16. And that's going to be 0, 1, 2, because it's just the most basic triangle, right? And it shouldn't be like this, it should be like that, and that. There we go. Okay, so we have the index buffer, and hopefully that will create the index buffer. Aha, okay, I see. I think I know what's going on here. Well, basically, the index buffer is missing, right? Because this, what is this? This is a nothing. A nothing burger. Right. This is initialized to 0. This is initialized to 0. So Okay, now it makes sense. I figured out. So basically, when the index buffer is 0, it's just going to draw triangles and it's not going to draw indices. That is why it actually works. So when I just draw this and I say that the elements are 3, right? Because it is 3, and instance is 1. Okay, it should work. It should work out of the box. Well, no, it doesn't. And it says that it needs to be passed as range as a reference, or, well, as a pointer. This is a pointer, not a reference. There we go. And doom. Okay, this is probably because I didn't define. Okay, let's see what it says. What does it say here? Pipeline object defines non-indexed rendering, but index buffer provided. There we go. This is why it happens, right? It defines non-indexed rendering, but index buffer is so yes, there is some kind of a switch that we need to do to turn on the indexed rendering. Okay, so hello Blargamel Jones. Yeah, there's one draw function and it changes based on what pipeline is bound. Default is SG index type none. Yeah, so I'm pretty sure that this was the index, the what defines whether whether it should do indexed rendering or not, is that thingy that was where was it? It was this index type pipeline description. So if I go to my pipeline pip desk and I'm gonna add this index type and I'm gonna say uint16. Let's see if that works now. And there it is. It works. So yes, this actually defines. You have to put it to index buffer. No, sorry, not that. To uint16 or a uint30. I really like that, actually. I really like that because, oh my god, I remember having to implement this in in C++, and my god, OpenGL code is the worst. So little type checking. Everything is just like these error codes that could mean 10 different things. And different ways to do things with different, like, oh, depending if you're using this thing, then this means that. If this is using that, then this means that. This is much more straightforward. But yeah, of course, it is kind of simplified, I guess. Nice. Okay, so there it is. It works. We can do index rendering, which means that we can just add a new vertex, all right, and then add a triangle. So let's try that. Okay, me also submit this for, yeah, let's say stream. Added indexed. Now doing indexed rendering. There we go. Okay. And I'm also going to say that we figured out this. Draw indices instead of triangle elements. But let's do a quad. Yeah, let's do a super simple quad first. Well, it doesn't need to be a quad, but let's do just another vertex. So I'm going to add one more. And let's put that to maybe 0, 7. Let's make it somewhere above. Yeah, something like this. So somewhere in the upper right corner, right? So this should be it. So we have 4 vertices now. Let's see if this actually compiles. I like how it actually aligned all the numbers automatically. Yeah, this still works. Even though this vertex exists somewhere here in the space, it doesn't render it. Because we're just using the first 3 vertices. Okay. So Blargamel Jones here says, Sokol is nice because 0 is almost always a valid value. If you just don't set an index type, it's just not indexed. Yeah, nice. Yeah, and let's add a new triangle here. So actually, let me put it like this, and hopefully we will be able to do it like this. So 0, 1, 2, and so the next one should be 1. Well, it should be 0, 2, 3, I think, if I'm not mistaken. Let's see if this works. Because what is actually the first vertex? No, it's not. What is the first vertex? The first vertex is 0, 5, which is the top one. Okay, the second one is 0, 5 minus, so it is the right one. So yeah, we go top is 0, 1, 2. Okay, so what we want to do is we want to connect this vertex. Should I paint? Of course I should paint. Yeah, so we have index 0, index 1, and index 2, right? And right now we are drawing a triangle like this, and it's drawn in a clockwise fashion, right? 0, 1, 2. We want to, we have another vertex, which is here somewhere, and that is number 3, and we want to make a triangle. Well, we want to make a triangle like this. So we want to do 0, 3, 1. That is what we actually want to do. So yeah, not this 0, 2, 3 or whatever I had there. So let's see. Does it work? No, it doesn't. Why is it not working? Because we are drawing just 3 elements. Did we forget that? Okay, let's. Yeah, because this is the number of elements, and we want to draw 6 of them, right? But this is not very nice, right? There it is. Woohoo! We have a quadrilepiped, or whatever, however you call this. Yeah, some kind of a 4-sided polygon. Anyway. Oh, this is actually a parallelepiped. No? I have no idea how do you actually pronounce things in English, because it has 2 sides parallel. But it doesn't have the 2 other sides parallel, so I don't think it's a parallelepiped. No, it's probably not called like that. Anyway. Anyway, yes. What was I on about? We drawn a quad. And what we want to do now. Okay, give me just a moment. Okay, for a moment I smelled something burning. And I was afraid that I left my my stove on or something, but no, it wasn't the stove on. It was coming from the outside. Just wanted to make sure I'm safe. Okay. Anyway, so yeah, we have the 6, but here's the thing: since we know that the index buffer is well, interesting. Okay, so how can we actually provide it with a number so that we don't have to edit this all the time? Okay, let's do. Should I do the index buffer as part of the state? Well, I don't need to save the state at all. That's the thing. I could provide a const, which is going to, yeah. Oh yeah, well, here it is. Here is how we can transfer the number so that I don't have to edit it every time I change. What I do is I'm going to create this as a const index buffer, right? And we have that like this. Okay. That should be it. It's not used, but I'm going to transfer the number of vertices. I'm going to add them into the state. So the state is going to have index count. And that's going to be a U16, because of course we're going to have the U16. Let's initialize to 0, just so that I don't need to initialize the state. And yeah, and so now I'm going to say state index count is indexBuffer.len, and there we go. So now what I can do is I can just plug this in and say, okay, instead of all this thing, use the index buffer. And here we go. And now I can use the index buffer. Index buffer dot, yeah, I can use that as the state in here, right? Say state index count. Okay, and that should work. No, it doesn't work. What does it say? Size, value size. Oh yeah, expected type const any opaque found 16. Aha, okay. So yes, this one takes a number of elements as U32. No, this is probably another problem. Wait, where is the problem? 40. Oh no, this is the top. Cannot implicitly cast double pointer to any opaque. What? Who says that? Who says that? In it. Referenced by. Index buffer. U16. Interesting. What am I doing here? Expected type. Constant found. Const. Ah! This is where I made a mistake. This is a reference. Oh, interesting. So what actually, yeah, I figured out that this is a double reference. This is a double pointer, sorry. So I had this pointer thing. So what happens here? Does this index buffer actually live through until the end of the scope, even if it has, even if this is a reference? So I guess this is going to be static. How do we call this? This is going to be like a literal, right? A static memory of a U16, I guess. Let's actually try. Let's see what happens. Is it going to propagate until the index buffer? And is the index count going to be 6? It's probably something that I shouldn't do. But let's see. Yeah, it still works, right? But I feel like it's much nicer to have it be a value and then grab a reference here. Yeah, I mean, there's pretty much no difference, right? I think because this is still going to be a, yeah, this is going to hold the value. The only difference is that, yeah, instead of holding the value, this holds the reference. I wonder if there is any difference there when it comes to optimization or anything. If I just grab the reference of a static memory and then pass it. Yeah, there's probably no difference. Anyway, so yes, solve that. We have the index count as a length of the index buffer, which is nice. Okay, so now what we can do is we can modify this index buffer as we please. So here we go. We have now another problem, and another problem. If you, yeah, now let's try to draw a circle. We did draw a quad. Done. Create a circle of vertices. So how do we do that? How do we create a circle? Well, here I just realized that I don't have to draw paint. I can do this thing. Excalidraw instead. Oh, look at that. Beautiful particles from back in the day. I don't need that anymore. So yeah, what is a circle? Well, a circle, of course, we cannot draw a perfect circle in the graphics. So what we have to do is we have to draw it as a set of points. We're going to have a set of points going around, and then we're going to connect them with a fan of triangles, right? So there's going to be a triangle like this, a triangle like this, a triangle like this, triangle like this, all going from one vertex, basically, right? Well, we should really start from this one, right? We start from this one, and that's how you create a circle. And yeah, so how do we form a circle of vertices? Well, we need to do a for loop of going through a set of coordinates, right? We can increase by a certain angle. So yeah, I know that Sokol has, as somebody has mentioned, Sokol does, oh, what does it says? Okay. Sokol does have a, is everything fine with the stream? I think so. Sokol does have some primitive helpers, but let's do it from scratch because this is a little bit of a challenge. So, when it comes to generating vertices, right? How many vertices are we going to have? Instead of these triangle vertices, okay, let me comment. Oh, yeah, one more thing I wanted to do is let's just submit this and say that we have a quad, drawing a quad. Cool. Yes. Let's remove that, and instead we're gonna first calculate how many vertices are we gonna have. Vertex count is gonna be, well, let's start with 12. 12 is gonna be easy to see, and it's gonna be maybe even 8, I don't know, but 12 is gonna be enough for a circle, I think. And it's going to be enough for a yeah, it's going to be enough for our first circle. We can always increase it later. The second thing is that I'm going to need to have some kind of a radius, right? So radius is going to be, yeah, 0.5, and that I'm going to do as f32. Well, now what we need to do is we need to go through 0 to vertex count, and we're gonna use an I to go through that. Is that going to work actually? Unused capture, yes, I think it should work. And we need to calculate the positions of each of the things. And how do we do that? Well, we need to convert a radius and an angle into a coordinate. So the coordinate is going to be, there's going to be some kind of an x, right? There's going to be some kind of an x, and there's going to be some kind of a y. And how do we do it? Well, it's sinus one thing, cosine other thing, something like that. I have to check. Okay, so angle and radius to Cartesian coordinates. Yes. Yes, there it is. X is radius by cosine A plus x0, whatever x0 is, where x0 is the center. Oh yeah, the center. Right, and we have the center as well. I have completely forgotten. So we have the center of x. Let's call it f, and it's going to be 0, 5, cy, which is going to be 0, 5. Okay, so for each of these, we're going to have a radius by cosine of a, which, yeah, the angle, which in my case, yes, of course, I also need to calculate the angle. The angle is also in radians. So here's the thing. I need to calculate the angle. And the angle is going to be, well, of course, it's going to be 1 by 360, but in radians, which is 2 pi, right? So 2, and do we have pi? STD math pi. There it is. It's a comp time float. We're definitely going to have to convert that into an F32, I think. But yeah, let's see. So yeah, of course, this is going to have to be F32, and yeah, this is definitely going to be int to float. No, float from int, which is I. And then we have to divide by 2 by pi. This is definitely going to be some kind of a compile error, and we're going to solve that as we get the compile error. Yeah, so we have a cosine of angle, and we have the radius by sinus of angle. Plus, of course, the cy, which is our center, and cx, right? That is what Google said as well. In mathematics, to calculate the Cartesian coordinates, yeah, cosine a plus x, and that is it. And that should give us the circle, hopefully. Okay, so what do we do with the x and the y? Well, we are going to add them into our triangles. And we're going to have the triangle verts. They're going to have the number of, it's going to be, of course, vertex count. Whoops, it's going to be, yeah, like this. The vertex count, the number of, the size of it, and it's going to be F32. And let's leave it undefined, because we don't need to initialize it, because we're going to set it inside of here. And yeah, so for each of the triangle verts, we are going to do a I, and that's going to be equals to, oh yeah, wait a minute, triangle verts is actually not, yes, because we have positions and colors as well. So this is not vertex count. This is vertex count by 7, right? Because there's 3 positions and there's 4 colors. So by 7. Let's call this attributes count or something like that. Let's just not have magic values. Attributes count. And yeah, so for each of these, yes, of course. Now I'm going to have to calculate this by attributes count plus 0, right? This is going to be, well, yeah. Can I actually grab a slice, which that would be nicer? Maybe. Let's do a const ci, or like start si, start index. That's going to be attributes count. Si, but yeah, let's do it with a slice later. Si plus 0 is going to be, that's going to be the x. But I say undefined. Should I do undefined? Yeah, let's do undefined. We're just going to have it be gibberish, which is probably going to be funky with the colors and everything. So the first thing is the x, which is x. triangle verts si plus 0 plus 1 is y. And the third one, which is position, oh, I have it at 0, 5. Interesting. Okay, so let's have it at 0, 5. Or maybe, okay, this is an, yeah, let's actually try it with gibberish. Let's just see what happens. Okay, so what does it say? Float from int must have a known result type. Yeah, so you can't just divide, you have to as it as well. I think that this is not going to work, right? Let's try to compile and let's see what happens. Because Zig likes to be very explicit about converting your values. So yeah, I think this should work. This should work, but yeah, the problem is that now we also have the problem with indices. Because the indices are completely wrong. But let's keep these indices because we should be able to see at least the first triangle. At least the first little pizza slice. Okay, let's try to build and let's see all the compile errors. There it is. Okay, incompatible types, use size and comp type float. So yes, first off, when it comes to the comp type float of pi, we have to convert it to F32 and we have to float cast it. Okay, we have to float cast the pi. That's first thing we have to do. And I think, yeah, there's definitely going to be a plethora of other things. Incompatible types, okay, yes, use size and F32 because I is a use size. So we have to convert that into a, let's see if it is actually going to infer. I don't think it's going to be able to infer. No, it's even the error lens here is, it's not called error lens. I forgot what it's called. Is going to complain. So we have to F32 and yeah, and this. Okay, next error. Expected float or vector type found use size. Oh yeah, because this needs to be float from int. Yeah, Zig is very explicit. Very explicit. Oh, this actually works. Nice, except we don't see anything. But it does work. We don't see anything at all. Maybe that's because it's the wrong order, right? Maybe it should have been... let's flip these two around and let's see what happens. If we just need to flip the order. No! Okay, there's something else is the problem. Something else is the problem. What about the radius? Okay, let's reduce the radius. Maybe the radius is too big because the CX and CY is also too big. Okay, I still don't see anything. I still don't see anything. So, okay, so this works, but oh my god, look at this. Look at this mess. Look at that mess. Yeah, let's put the pi into a separate, yeah, let's just cast it to F32. But here's the thing, you don't need to have a float cast as if wait a minute, expected, did I forget? Okay. Yeah, this should work. You don't need to have an as F32 if you have F32 here. So you can actually remove that and then it will automatically float cast because it can coerce, it can infer what the type it is casting to, as you can see. So that is pretty cool. And let's also do yeah, I don't know. Should I convert to F32 as well? Now let's keep it like this. It's understandable. Well, this is much better than having the angle be okay. So yeah, but should I should I divide? Should I divide or multiply? No, I should divide, right? Or should I divide 360 by I? No, wait, it doesn't make any sense. Yeah, if the angle is 0.1. What the hell am I doing? Okay, that didn't make any sense. I actually need to do this divided by size. Oh my god. Okay, so there's gonna be a lot of okay, there's gonna be a lot of yeah, this needs to be first divided by vertex count, right? Which also needs to be cast, because this is a vertex count is containment. Oh Jesus. Okay. Is there any kind of an easier way to do this, or do I have to just do it with all the float casts? That is kind of annoying. How can I call this? Angle. Yeah, let's actually do like an angle difference before everything. And angle difference is gonna be 1 divided by vertex count, right? But it's gonna be F32. It's gonna be F32, and we're gonna do a 1 by. Can I do a float from int like this? I wonder if this is going to work. Nope, because it can't infer the type. Okay, auto discard, yes. Angle diff. So instead what I'm gonna do is I'm gonna multiply this with an angle diff, and hopefully that will work. And I don't think we need, right? We don't need multiplications and everything. We don't need the parentheses. That is what I was trying to say. We do still need to convert I. Right. Okay, I still don't see anything, and I'm not sure exactly why. Oh, wait a minute. Did I say... Oh my god. Oh my god, rookie error. Did I say 022 from the beginning? And nobody in the chat is complaining, so... great. Okay, so 012. What happens now? Do we see anything? We still don't see anything happening on the screen, which is strange. Let me reduce the vertex count to like 5 so that the triangles are bigger. Okay, let's actually do a few triangles. So that's going to be 0, 1, 2, right? The first one is going to be 0, 1. Wait, 0, 1, 2, right? It's this one on the beginning of the... But then we need to do 0, 2, 3. And then we need to do 0, 3, 4, right? So let's do that. 0, 1, 2, 0, 2, 3, 0, 0, 3, 4. Okay, there we go. Well, that's enough, I think. Three triangles should be enough. And they're not showing. Okay, so what did I fuck up? Where? It could be anywhere. Okay, so why is this not... Another rookie mistake. Another rookie mistake. There it is. There it is. We have a little part of a sphere, of a circle. Interesting. Okay, but why is it not the whole circle? Is it because it should be divided by pi and not by 2 pi? Interesting. Angle difference. Or maybe it should be -1, right? Because because the last the last vertex should be the first. 0, 1. Okay, so if I say 4, right? That's 0, 1, 2, 3. That's 4 vertices. Yeah, no, that's still the angle is still 90 degrees, which is 90 degrees is a quarter of a pi. A quarter of a circle, which is half of a pi. So it still makes sense. Yeah. What? I am doing something strange somewhere. And also, why is my circle... Why is my circle over there? It feels like it's in the upper right quadrant, right? Entirely. Even though the center is at the middle. So that is strange. There's multiple strange things happening. Okay. So since we have 5 vertices, let's do 6 vertices. No, let's do 4 vertices, because this should be a square. That is something that should be known to us, how a square looks like. All right. It is absolutely not working as intended. 0, 1, 2, 0, 2, 3, 0, 3, 4, and the last one is 0. What should be the last one? Because the vertices are... Oh! The vertices are... Wait, number 4 doesn't even exist. Because there's only 3 vertices. There's only up to 3. So if I have 4 vertices, what needs to happen is there's 0, 1, 2, 0, 2, 3. Oh, there is actually just 2 triangles. That makes sense. 0, 1, 2, 0, 2, 3. And that's it. Right. Of course. So the number of triangles is actually 4. Yeah. And this is absolutely incorrect, because I am definitely doing something wrong here. Okay, let's not divide by 2. Should it be multiplied by pi and not divided? I don't think so. Yeah, there's something very wrong there. What if I multiply by pi? What binary operator has white space? Oh, okay, of course, because this is not a pointer. Okay, there's something so strange happening. What if I put this to 0? Now it makes sense. Okay, so it was actually going below 0 automatically, right? Yes, but why is it only the top part? Okay, I'm doing something wrong. Drawing a circle is much is harder than I thought. Okay, can I fill this up with zeros? Can I fill this up with zeros? Please. Okay, yes, zeros. Expected type. Okay, it returns the type. So that's actually should be here. Yeah. Okay, so yeah, I'm just gonna move this one to here. But I don't think it's the problem with zeros. Yeah, it's not. It's something else. It has to do with my beautiful calculation of x and y. X and y. Attributes count. What am I doing wrong? Pi is fine, but then the angle needs to be in radians from the polar coordinates. Yeah, I mean, it's should be pi by 2. It should be, yes. Of course. Of course, I should not have divided by pi by 2. Yeah, I don't know why I even divided. But of course it makes sense because this is the angle difference in 0 to 1, which I then need to convert to 314 by 2. Yeah. Simple maths. Yeah, there it is. We have a circle. Although this is not a circle. This is a deltoid. Or a rhombus. So now what we can do is we can just increase the number of vertices. And I can put it to 8, for example. And magically it should not draw the entire circle, but only the half. Yes, there it is. Okay, so this draws only half of the circle. And we need to make it draw the entire thing. And how do we make sure to do that? How do we do that with an index buffer? Right, so now we need to actually fill up the index buffer procedurally as well. And this, we figured out that we always need triangles as many as vertices minus 2, right? So triangle count is going to be vertex count by 3 minus 2. No, not that, but wait, vertex count minus 2. This is what I meant. Right, so you shouldn't be able to generate one with vertices, yes, with like less than 2, because 2 doesn't make any sense. If you have just 2 vertices, you cannot make a circle out of 2 vertices. So we need a minimum of 3 vertices to generate a circle. Try count. So, and now, since we know the try count, we can pre-allocate the buffer. We can say index buffer is try count u16, but should we mem allocate to 0 or not? No, let's keep it undefined. So I'm gonna make it the type of u16 and equals undefined. And now what we can do is, instead of defining the index buffer ourselves, we're gonna go through a number of triangles. So oh, and by the way, this is the index count. This is not the triangle count. This is the triangle count. But the index count is going to be try count by 3. Yes. But I'm going to go through 0 to try count. And I'm going to do an index of that. Let's do try instead. And triangle, we're going to say that index buffer try plus 0. It's always going to be 0, right? And that's the first. Actually, we shouldn't have deleted that. I can use that as a reference. So here we go. So let's keep that as a reference. And I'm going to just comment it out so that we don't look at it. So as you can see, the first vertex is always going to be 0. And that is why we make this the index buffer try plus, well, this needs to be try by 3 plus 0, right? And then the first one is going to be some kind of a, yeah, it is actually going to be the same as try, but plus 1. So the first one, it's 0, and it's going to be try plus 1 is going to be 1. And the second one is going to be try plus 2. So there it is. This should give us the entire circle, no matter the number of vertices. So let's see. Yes, we also need to make sure that, yeah, index buffer is undefined and everything, and index count equals index buffer len. Yeah, that is something that would keep it in this state. But yeah, actually, let me put that over here. Makes more sense to put the comp time known value first. Okay, so let's see. Is the whole thing going to render? No, because we have an error. And what does it say? Expected type U16 found U size. Of course, we need to convert the try. So this is going to be, let's do a true. Let's call it the true. Great naming. Try U. Yeah, maybe try U is better. And that's going to be U16. And we're going to do a int cast. So we're going to cast from one type of int to another. And this try U, we're going to just replace these. There we go. And hopefully this will work. No, what does it say? Expected type U16 found U size. Wait a minute. No, this is not. Oh, this is the one that I need to change. Not this. Okay, so this could have stayed the same. There it is. Beautiful. Look, it works. Oh my god. What am I doing? What have I done? I don't think this is it. What is this? Is some kind of a fish? What is this? Oh my god. I accidentally designed a fish. Is it so hard to draw a circle? This is great. Okay, so where did I go wrong? Oh. Ah, rookie mistake. Rookie mistake. Look at that. Look at that. Wow, it works, except it's not a circle. It's an oval because it depends on the size. All right. So since we can draw an 8-sided circle, right? Let's just draw a 64-sided circle, because why not? No, actually, let's randomize the color. Let's randomize the color. Si plus 3 can be is there like std rand? Yes. How do you use the rand? And now I need to remember. You probably create one from nothing. Deprecated. Use random instead. The engines provided here should be initialized. Huh. Use random instead. Cryptographical secure. Nice. You should use something else. Okay. First, let's be proud that we drew a circle. Drew a circle. Circle. 8-sided. Black and 8-sided. Okay. So, if I put something else. Oh, yes. 3, 4, 5, 6. We also have the alpha. I completely forgot about the alpha, but the alpha looks like it doesn't matter, right? So this should be gray now, sort of. Hopefully, yes, it is gray. Oh, and it's even going away and in. Does it have anti-aliasing? Oh my god, it has anti-aliasing by default, I guess. Sokol. Okay. Not bad. All right. So, yeah, this I want to turn into a random, but let's do that with a, I guess we need to do a rand, and that's going to be std random. Is it better to write things like this? And do I need to give it a size seed? No. What does it say? A rand float, but I think it changes the type, right? And it's not used. I think it changes the type, so it can't be a const. Missing struct field pointer. Okay. It does want a pointer. So is there init? Yes. Why is there a pointer for a random? Interesting. How do you use it in it? How do you create a random? Oh, I think you actually use a different... Okay, so this is not the type. I think std random is just... Is it not a type? The engine's provided here. Yes, so I think this is just... I'm actually not sure. Should I take a init with a field? Yes. So yeah, I can do whatever. 1, 2, 3. Init, and that actually returns a PCG, which then we can... Oh, so this is... Yes, I see. This is actually an interface. Random is an interface that PCG uses. It's actually kind of easy to figure this out when you have coded in Zig for for a little bit. But it doesn't really say that. Yeah, that is kind of strange. So random itself is an interface, you know? Which then all of these use. That is why you can do it like this. You can init, and yeah, let's actually remove that, and let's see, let's remove the whole thing and just compile, and let's see if this works. Yeah, it does. So yes, if you want to get a random, you basically say random. Yes. Well, we are gonna grab a random from there. The question is whether this still exists, right? So rand, that's just the interface, and we're gonna have a float of f32, and let's actually just log info just to test it. So I'm gonna do it like that, and we have a that, and let's do it a couple of times just to see if that works. Nope. Expected type random found const random. Yeah, so this cannot be a random. This cannot be const. Expected type random found const random. So yes, maybe this can't be created like this. Maybe it needs to... okay, maybe I need to do it like this. PCG and then const random. Const rand is PCG random. Something like that. No, still not. Oh, there it is. It is actually working, yes. And let's read. Yes, there it is. There are 3 different numbers. Nice. But this is a completely random float. This is not a float that I want, because float actually gives you... Oh no, it is between 0 and 1. It's just that this representation is awful. Yeah, it's a -1 exponent. So it is between 0 and 1. Okay, so let's just do that. Let me remove that. And instead of using the colors, I'm just going to do a rand float. There it is, of f32. Of f32s. For R, G, and B. And alpha is always going to be correct. So we should have a little bit of a funkier circle. There it is. Nice. Very, very nice. So now we can be aware of how many vertices there is. the interesting thing is we can notice that this is actually the 0. This is the 0th vertex, 0, and then goes around. Yeah, not bad, not bad, and it's still flashing. Let's make it also bigger. Let's make the radius a little higher. 0.7, that's better. There we go. Nice. Okay. Okay, now that we have that, we have our colorful circle. Colorful circle. Now that we have that, let's render it as, yeah, let's increase the number of vertices. And let's do 100. Because why not? Because why not? Boom! Look at that circle. Look at that funky circle. It's so detailed. Wow. Wow. Beautiful. Well, it is an ellipse. But at least this is kind of strange. At least it works. Yes. Nice disc. Beautiful. Just beautiful. Incredible. So there we go. Our task has been finished. What we could do... Well, how would I actually make the circle not squashed? For example, that is one thing. I would need to pass in the size of the window to the shader. Or aspect ratio. I wonder if this would work. Yeah, well, we have basically finished. I did say that I wanted to make it move. Create a circle vertices, done. Draw the circle, done. Make the circle move with uniforms. But let's actually make the circle not stretch. Meaning not with the size of the window. So what we need to do is we need to basically pass in a scale into the GLSL. Or just the ratio. So I am going to need a uniform block, but in the VS. So let's call these VS params, and this is going to be float aspect ratio. Let's call it like that. And what I need to do here is I need to position X by equals aspect ratio, and I need to compile the bat. So when we compile, oh, it does say can't modify shader input. Okay, we cannot modify the shader input, so we are gonna just add it here. But yes, I need to actually modify. Can I modify the output like this? Yeah, can I modify the output? Like, just put a GL position here, .x. That would be interesting. Let's see what it says. Required can't modify shared input. Did I save? Did I? Okay, I think it still won't work. Oh no, it did actually work. It did actually compile. I just didn't notice it. Okay, so what we need to do now is we need to have oh, this is actually fs params. This is not vs params. And where are the vs params? Yes, state fs params. And this is fs params. Let's try to build it again, and let's see where I fail. Yes, I failed somewhere, because what I'm doing here is I'm multiplying with 0. So we need to initialize this. Can I initialize it like this? Actually, I'm not sure. Let's see. No, looks like you can't initialize. Can you initialize parameters, uniforms? Hello. Why are you curious about Zig? Because I want to perhaps make my future game engine in it. But also with Sokol. And I kind of am tired of C++. So what am I doing wrong here? Wait, am I... Yeah, I'm pretty sure that this is the fault. This is probably the fault. Let's run this again. Syntax error, expected equal, expecting comma. What the hell? Expecting equal. Syntax error. Where? Oh, so I think it doesn't even allow this. Expected equal, expected comma, or semicolon. And that is in GLSL 3, which is here. Interesting. So I don't think initializing is actually allowed. So this compiled correctly. Okay, let's see. OpenGL initialize uniforms. Can you initialize uniforms? Uniforms are intended to be set rather than with. However, you can initialize them to default value using GLSL Whoop. Initializer syntax. Well, there it is. Okay, maybe you need to initialize the whole block. Okay. Let's see. Did you try Rust? This is some kind of a proposal. Okay. Okay, look. I'm not gonna do this. I'm not gonna do this. Let's just do... I'll come back with the Rust question in a bit. I just want to fix this. Okay. So, I need to pass 1 for my aspect ratio. And let's do it like this. Shader. Oh, it doesn't have VS params. How come? How come it doesn't have VS params? Okay, this compiled correctly. So it should have VS params, no? There it is. It does exist. And the thing we have is aspect ratio. And that's going to be 1 by default. All right, let's see if that compiles. I don't know why I wanted to say IntelliSense. It's not IntelliSense. Yeah, it compiles because it does exist. Okay, but we need to set the bindings to apply uniforms as... Hey, wait a minute. It was actually working, right? So do I need to apply uniforms or not? It was actually working. So what if I initialize to like 0.1? No, okay, something is not working. This is weird. Did I remove the GLSL line? Yes, I did. This is why it works. Okay, so this works. Yeah, I completely forgot. Main. We have the state, we have the VS params, aspect ratio. Okay, let's put it to like 0.5 so that we can see it. VS params, yeah, and I need to assign these to the shader. It's absolutely necessary. So this is gonna be VS slot VS params and VS params. Let's see. Nope, it doesn't work. Why doesn't it work? It has no member called VS params. The state doesn't have it. Or is it shader? No, it's the shader. How come? This compiled correctly, right? Did I name it wrongly? VS params, FS params, aspect ratio. It does exist. And it did compile successfully. Right? Let's go into the compiled shader. Yeah, I mean, there it is. So what's the problem? Slot VS params, state VS params. Ah, there is the problem. The shader doesn't have, the type is capital V. That is why discovery also didn't work. There it is. We can compress circle now. Okay, so now we have to set the actual aspect ratio depending on the size of the screen. And how do we do that? How do we actually calculate the size of the screen? What is it? Sokol window. How do I access the window? Window. Does it have dot window? No. Where is it? Is it in the app? Consume event. Oh, height. There it is. Height F. Height F. Width F. I guess you can use it directly. So we need to calculate the ratio, and const ratio F32 is so it's gonna be width divided by height, right? Sokol app height F. Okay. And now that we have the ratio, we're going to pass that, we're going to override state VS params. What is it? Why doesn't it work? There's no IntelliSense. Okay, it's called aspect ratio, of course. Dot aspect ratio equals ratio. Well, we don't actually need the ratio. We can just automatically put it in here. All right, so now that when I'm binding all these vertex shader parameters, we should have the aspect ratio applied because we're binding every frame. There it is. There. Oh no, wait. This is not it. Okay, did I get the vertex ratio wrong? The width by height, aspect ratio, and these VS params get passed in, right? Yes. Am I actually using it? Let's check. Aspect ratio. I am using it, but I'm using it as the output. Maybe this is the problem. Let's see. Yeah, let me also make sure that I'm using the latest version of the shader. Let's see. Hello, two-step. Nice to see you. Okay, I am using the latest version. So is sokol width and height, is that the actual height of the screen? Maybe it's the other way around. So yes, I've got a question. Why not Rust? And it's still not working. Oh, it is working. It just updates later. Oh, okay. So it doesn't update every frame. That's the issue. Interesting. So is it possible, I wonder, to update every frame? But there it is. We got a perfect circle on every size. Looks pretty cool. Looks pretty cool. It looks like some kind of a flag, you know? It's beautiful. Absolutely beautiful. So yes, I think that's basically it for today, for the stream. But yeah, I got a question. Why not Rust? Well, I did try Rust, and Rust is it's just not fun. It's just not a fun language. Rust is really good when you want to make like super safe software and something that never fails. Um, but I don't think it's the best language for games. That's what I think. Um, yeah, because in games you need to iterate quickly and you need to do things in a dirty way, and Rust is just like, no, you can't do anything in a bad way. You just need to handle every possibility, and uh, once you start doing stuff with I remember I was trying to do something with splitting an array for different threads and calculating the values, and oh my god, was it complicated. Oh my god, was it ridiculous. I don't know. It's like this is something that is not supposed to be complicated, but then once you start doing things not the way that the Rust wants you to do, it becomes extremely hard. And yeah, and then there's lifetimes. Lifetimes are just evil. And yeah. And then in the meantime, so I started trying out Rust way long ago, like, I don't know, 6-7 years ago or something like that. But then in the meantime, Zig came out, and it was just like, oh, this is actually just a better C without all the C++ bullshit. And then I was like, my god, that sounds good. Let's see what it is. And then I figured out that it actually has not just one or two, but like 30 different things that is pretty cool about it. You know, the fact that it has integrated build system and the package manager, although the package manager came in 0.12, or was it 0.11? I can't remember. And yeah, and a bunch of other things. Comp time, of course, for metaprogramming. Being able to include C and just use C functions, that's fucking incredible. All the different pointer types it has to make it, to disambiguate working with them. And yeah, there's a lot of things. Yeah, I love the safety around numbers, although it can be quite annoying, like like in this case. Where was it? Where I was actually converting everything to floats, and then you have to as float from int, and oh my god. But look, actually it makes sense, and I didn't shoot myself in the foot by dividing a integer by integer and then not getting a float as I was expecting, right? Which is something that you would do in C++. So There you go. That's my reason. Um, but yeah, I am actually feeling really tired now. I'm barely keeping alive, as you can hear in my voice. I was a little bit more enthusiastic at the beginning, but now I'm getting slower and slower, and my eyes are closing. So I'm gonna end it here, and look at that beautiful flag we have. A flag of something, a flag of Zig development, flag of game development, uh, and yeah. So with that, with this as the cover, well, we can also resize. There we go. Wish I could do a full screen, but I don't know how. Anyway, uh, yeah, I don't know. I'm pretty sure that there's like a sokol begin in it. So does it have an init? Oh yeah, this is where you put full screen. Full screen is true. Let's try that. Oh, I need to kill it first. There it is. I hope you can see it, actually. I hope you can see this on stream, or maybe not. I am actually wondering if you can see it. Can you see it on stream? Because I'm not sure if this is using integrated card or the GPU. If this is using the dedicated GPU, oh my god, Sokol is the best. Please tell me, can you see the flag, or do you see the code? Yeah, I can see it. Cool. So that means that Sokol already fixes my biggest issue that I had with Shakedown. And even Godot 3, which is that it just uses the integrated GPU. But this one obviously picks which one do you want to use. I mean, it obviously picks the more powerful one. Cool. Okay. So with this hypnotic screen, I'm leaving you, and see you soon. Goodbye. This might have been a one-off so-called zig, but I'm not sure. Maybe I'm gonna change my mind and do something with it. But yeah, it was a nice way to try Sokol, and yeah. See you in some. Yeah, I'm waiting for Steam to respond about my page and everything, and hopefully by the end of the week there will be a Steam page for Shakedown. Just so you know, this was just like a one-off stream. Yeah. Anyway, see you next time. Bye.